Hello, so we are looking at section 2.8. It is about one-to-one functions and inverse functions. They have a relationship, that's why they are together. So we say let y is equal to f of x be a function, then the inverse function of f is a function denoted by this symbol. This is f, we read it as f inverse. We don't read it as f raised to the negative 1. Remember, this is f inverse. And it exists only if the function f is 1 to 1, and then it satisfies that f inverse of y is equal to x if and only if y is equal to f of x, which means whenever you have y is equal to f of x and f of x is a 1 to 1 function, we can write this, and if we see this, then we can write that. So they are that's what if and only if means. That this side, let me call it like p, and this is q. So the p statement gives us the q and the q gives us the p. Then we say if and only if. And so for example, what it means is that if you see that f inverse of 10 is 8, then it means f of 8 is equal to 10. So inverse function kind of acts on y. That's what happens. So basically what the inverse function undoes what y the f has done. Okay, so if you notice here, that's what we are saying, that the definition said that if f takes x to y, then f inverse takes y back to x, and then vice versa. If we start with f inverse, whatever the input, it will give us back the input that we had. So for example, here f of 1 is 5, then f inverse of 5 is 1. So you see, this is the input of for f, and this is the output by f. But now this the f inverse will be applied on the output, and it gives back us our initial input. Reverse function so basically an inverse function reverses the method of the function. In algebra, if f of x is equal to 2x, then the inverse function of f of x will be the function g of x equals x over 2. Why? Because here we are multiplying x by 2, so what will be the inverse of multiplication? Division. So that is what happens here, x plus 2. So for example, if your f of x is as simple as 2x plus 3, so notice here, how do we think of this? We say first we multiply x by 2, then we add 3 to it. So what will be the reverse function? So reverse f inverse x will be now. So we do the opposites of addition is subtraction, and opposite of multiplication is division. So first here in this f function, the multiplication has been done first, and then 3 has been added. So here we will go the reverse. First we will subtract the 3 from x, and then we will divide by 2. But this is not always how we will find the inverse function, because when the function is complicated, we cannot think backwards if there are too many steps. So there is another method that I will show you later in this section, how to find the inverse functions. But basically, in x, and what happens in the function and the inverse function, the x and the role of the x and the y, they get interchanged. So the y becomes f, the x, and the x becomes the y. Now this is a very important warning here. So often students think, this is -1 power. Now we know that if I have a raised to -1, we can write it as 1 over a, and this is what we say is in numbers. So when we have real numbers, then this is true. This is the property of real numbers, that a real number raised to a -1 becomes the 1 over that real number. But this -1 is on top of not a real number, but on a function. So in a function, we don't make it 1 over this or neither this. So now it's important to, before we start finding the inverses, we have to know what are one-to-one functions, because inverse functions exist only for those functions which are one-to-one. So here is the definition. A function f is 1 to 1 if no two elements in the domain of f correspond to the same element in the range of f. So if you recall, this is a function and this is also a function. We both are functions, but first one we say is 1 to 1 and the second is not 1 to 1. Okay, and why? Because here more than these 3 is going to this number 4 and also -2 is going to number 4. So 2 arrows are stopping or arriving at a single point, which is does not make it 1 to 1. It is still a function but not 1 to 1 function. So why is it not 1 to 1? Because remember what we saw up there, that if I see, so for example here in this case, if I see if -2, f of -2, we know that f of -2 is -1. So according to, if we have an inverse function of for this, then f inverse of -1 should be -2. Is that what is happening here? Yes, that can happen, right? F inverse of -2 can be -2. But if you look at this g1 function g, we know that, for example, the g of -4 is 15. So if we have an inverse of this function, then the inverse of 15 should be equal to -4. But we see the inverse of 15 is -4 and also 4. So which cannot happen in a function. Starting from one point, 2 arrows cannot start with 1 point. So we are going this way, so we have 2 arrows. So this is not 1 to 1. Again, not always a function will be given in this form. So how can we figure out whether a given function is 1 to 1 or not? By either algebraically, or like if the equation is given for the function, how can we find it is a 1 to 1 function? And also graphically. So for algebraic method, there are you can pick a value for y and solve for x. So if you get one value of x, you should do it for several values, not just one, but 3 or 4 values. And if you see every time you are getting only exactly one value of x, then the equation represents a 1 to 1 function. But if you are getting more than one values for x in your result, then it means the function is not 1 to 1. Graphically, we can use the horizontal line test. So it is like the vertical line test, which we use to check whether a given function is whether a given relation is a function or not. So here with the horizontal line test, we can check whether a given function is 1 to 1 or not. And the horizontal line test says a function is 1 to 1 if and only if no horizontal line intersects the graph more than once. So horizontal line. So for example, if we have to check which of the following graphs, or which of the following, actually I should have said functions, represent a 1 to 1 functions. Okay, so you can graph them and check whether they are 1 to 1 or not by horizontal line test, or as I said. So let's try doing this one by picking a value for y. Let y or f of x equals, let's see, 1. Okay, so what do? I place 1 for f of x, so I get 1 equals x minus 2 whole square minus 3. Do my algebra, so I add 3 to both sides, so I get 4 is equal to x minus 2 whole square. So what do? I can do it in two ways. I can expand the right hand side and then I get a quadratic equation and then solve it, but also I can do this. From here I can get x minus 2 equals plus minus square root of 4. So I take square root on both sides, so which will give me x is equal to plus minus 2. X minus 2 is equal to plus minus 2, but then we have to add this 2, so it will be plus minus 2 plus 2, so which will make x is equal to 0 or 4. So I got two values, so this is not 1 to 1. Now if you recall, this is what it is, just a translation of the x square function. See, base function is x square, so this is a translation. So x square function is not a 1 to 1 function. Why? Because its shape is like this, so if you horizontal line passes through 2 points. Part B, so I'm going to do now just check with the graph only. So I'm going to, I know that the graph of g of x looks like this, which is a 1 to 1 function, because if you draw a horizontal line, no matter where, it only crosses at maximum at 1 point. And this function, given one, is just a translation of that, right? So it's like you move 2 units here. So this means that our function is 1 to 1. So you can try doing these ones. X cube plus 2, again you can just figure out with the graph. X cube function is itself, because this is again translation of x cube, so x cube itself is 1 to 1, so translation up 2 units will also be a 1 to 1. The next one is the absolute function, and absolute function is not 1 to 1 because it's a v. Remember, the absolute function is like a v, so which is something similar to the parabola. So any horizontal lines will cross in more than 1 point. So we have not 1 to 1. Okay. So the 1 to 1, so 1 to 1 functions possess inverse functions. Okay, or the inverse functions exist only for functions which are 1 to 1. So let's look at this example now, because we saw that this is a 1 to 1 function. So let's look at some things here. So what is the domain of this function? Domain of f is, so here we have only numbers, so we can write them in a set. So domain of f is number, these elements in the first set, which is -4, -2, 0, and 2, 4. So I have -4, -2, 0, 2, and 4. What about the range? So range is -3, -1, 1, 2, 1, 1, 3, 5. Now let's look at what will f inverse look like. Okay. So f inverse will be, and now the second set will become the first set. And the first set will become the second set. So they switch their role. Okay. So, but now when we map them, so here from -4 we were getting to -3. So in the inverse function here, which I will write here f inverse of x, we will -3 will go back to -4. So -1 will go to -2, 1 will go to 0, 3 will go to 2, and 4 will go to 5, 5 will go to 4. So this is the inverse function. Now let's look at the domain and range of this. So the domain of f inverse is -3, -1, 1, 3, and 5. And range of F inverse -4, -2, sorry, -4, -2, 0, 2, and 4. Now, if you compare it with the domain and range of pair, so you will see that domain of F inverse is the same thing as so the domain of F inverse is the same thing as range of F, and the range of F is the same thing as domain of F. Okay, so that's why we say X and Y get switched, or they switch their role. So we'll talk about more and see examples later in the second video.